Hi, let us look at this problem under proofs with algebraic expressions. Here we are told that if the product of any two numbers, a and b here stands for any two numbers, is greater than zero means positive. If the product of any two numbers are positive, then which of these proposals, a, b, c, d, are always true? Always true. Okay, so remember, in logic, if a general statement is made and you disagree, or you say that that general statement is not true, the only way to disprove it is to come up with a counter example. That means bring one example that does not hold. Then that will be enough to cancel that general statement. For example, if someone makes a statement that all the students of a particular class are of age 14 years, if you disagree, then all you need to do is to pick out one student from that class whose age is not 14 years. If you succeed to bring out one student whose age is not 14 years, then that will cancel the statement, that will disprove the statement which says all the students in that class are 14 years. We're going to use that approach to try to verify the proposals A, B, C, D in this question. Now, for simplicity, let us just take uh, two scenarios where we have positive and negative numbers. Okay, positive and negative numbers. Now, let's start with A, proposal A. Do we agree that if the product of two numbers is positive, then their sum is also positive? I disagree. So I come up with an example. Let's take two numbers, for example, 2 and 3. And we also consider the negatives, 2 and negative 3. Let us see. All right. The product of these numbers, their product is positive. All right. All right. Now let's check their sum. Their sum is positive. Okay. All right. Now let's come over here. So here it holds. Let's come over here. Their product is positive. Now let's check their sum. Their sum, remember sum means addition, is what? It's negative 2 minus 3, which is negative 5. Now their sum is not positive. So you see, we have seen a situation here where the product is positive, but the sum is not positive. So this statement is not general. We have come up with a counter example which disproves that statement. So that statement is wrong. We now take B. We now take B. It says that if the product of two numbers is positive, then the first number is positive and the second number is also positive. If we look here again, we take this first case again, the same scenario. Let's write B there. We're still working with the same examples. We see two numbers whose product is positive, and the two numbers are positive. The first number, 2, is positive, and the second number, 3, is also positive. Okay? 2 is positive, 3 is positive. That holds. Now, but pay attention again here, look here. We have negative 2, negative 3. Their product is positive. But do we have those numbers to be positive? No. 2 is negative, so this one fails, and 3 is negative. Therefore, this is not always, pay attention, we said always. It holds here when the two numbers are positive, but when the two numbers are negative, this condition holds, but this one do not hold. So this is not always true. It is true only when the two numbers are positive. So B is partially true only for positive numbers. Now let's go to C. C says if the product of two numbers is positive, then the two numbers have the same sign. Now, if we look carefully here, we see the same sign. The sign of 2 here is positive, the sign of 3 is positive. The sign of 2 here is negative, the sign of 3 is negative. They have same sign. Let us verify this case. It just gives us exactly what we had. You see, first condition holds, the product positive. And then second condition, their signs are the same. Greater than 0 positive, greater than 0 positive. It holds. Now coming over here, let us check the two. Now the two numbers are negative, same sign. All right, they are negative, same sign. What is their product? Their product is positive, and they are same sign. So it holds, and it holds here. Therefore, the proposal C is the right proposal. If we look at D, D says the first one divided by the second must always give us a negative result. Now look here, we already validated this to be true. Let us check if the first one divided by the second will give us a positive result. This does give us a negative result. This does not give us a negative result. Therefore, this one is wrong. Thank you.